Good afternoon is Joe Bassett. When Joe joined the family business at the age of 22, Don Equipment was in the midst of a struggle to stay alive. Despite this, Joe decided to make a go of it because he loves the company's focus on innovation and the maker's culture. The culture continues as the company's core driving focus today and has helped the company recover and grow. As its CEO today, Joe continues this inventor-driven, product-first mentality by remaining personally involved in the product development, and Joe has now launched a new company, Underground Agriculture, with a product line focused on soil health. Joe believes that healthy soils is the right pathway to maximize profit. And through Underground Agriculture, he is committed to manufacturing equipment that will help farmers adopt, nurture, and succeed in progressive soil-friendly farming methods at prices progressive farmers can afford. There's a number on that. I didn't know that, Joe, so that's good. Please join me in welcoming Joe.
Thanks. I'm turned on? Okay. Okay, wow. I left my home in Illinois at 4 o'clock this morning, and a bunch of dominoes clicked off, resulting in me being here and having my presentation loaded with 5 minutes to spare. So I'm really, I love things that work out. I love things that work out despite everything being stacked against them. So, wow, large group, thank you for having me. So, as I said, Don Equipment forked this year into 2 independent brands, the Don Equipment brand, which many of you are familiar with, and the Underground Agriculture brand. And today, there's a lot of things we can talk about around our traditional products, but today I'm going to focus specifically on our soil health and cover crop products. If you look at the spread between the left chart and the right chart, my hypothesis is that a large amount of the value creation in the industry is actually being absorbed by input suppliers. Is that an accurate hypothesis? Okay, so all right. So I mean, I don't want to put the input suppliers on blast, but I am. Oh, yeah, the input supplier just cut the screen. Okay. Take him off stage. So how it all started. So I was looking around the internet and I saw this invention for this cover crop roller crimper model ZRX that was actually invented by a Mennonite gentleman in Pennsylvania. And I said, that is a great invention. And I got in the car and I drove out to southeastern Pennsylvania and I sat down at the kitchen table at this Mennonite farm with Charles and Ruth, and I said, you're going to do a deal with me. And Ruth was quite a negotiator. And because I was like, you know, a lot of times when you look at planting into cover crops and all sorts of things, it hasn't been very scalable. So the other aspect of underground agriculture, I said, okay, look at and this was now 4 years, 5 years in the past. Look at the regulatory pressure which is happening in southeastern Pennsylvania in the Chesapeake Bay watershed. And I think you guys are starting to see some regulatory pressure around the Great Lakes here in southern Canada. And my other thesis was that, okay, this regulatory pressure is going to extend itself across the rest of the country. So we can kind of skate to where the puck's going and get ahead of it. Well, I no longer believe that's the case. At least in the central United States, I no longer believe that like water quality regulation will have any meaningful impact on farming practices. There just isn't the political will, and not only that, I don't think it's effective. I think the only thing that's going to be effective is making farmers more profitable with soil health practices. Conservation agencies have been trying to regulate, and incentivize conservation practices for 200 years in the United States to very little effect. There are fewer no-till acres in Illinois now than there were 20 years ago. So here's me, a bit younger, standing with Steve Groff way back in the day, coming out there. And this is a product that works really well for planting into tall cover crop stands. And we kind of naively got into it and started selling it to some people. And it worked sometimes and it didn't work other times. We'd have really mixed results. The thing we realized was that most people, we no longer, if you're going to be growing a cover crop and letting it grow 8 inches tall and then terminating it, we don't want, that's not in our customer profile anymore. In fact, I'm sort of ambivalent about these cover crop practices that result in limited biomass growth and then you terminate it. I think it's sort of you're not maximizing the return from the cover crops. What we're really interested in, increasingly, to circle back to my first point, is organic no-till. Because it is my personal belief that organic no-till is actually the highest profit system possible, where you get the absolute maximum dollars out with the absolute minimum dollars in. And I'll kind of go into, throughout this presentation, my organic agnosticism. I'm not like an organic zealot in any way. For me, it's just like, okay, these are engineering problems. How do we make the most money? How do we deliver results? And so we had some really good results. Organic no-till soybeans are something you can do today. We have a system in place that could empower end users to succeed with organic no-till soybeans today. Corn is a little harder. Soybeans are in our sweet spot. Like, soybeans are our focus. We have to just like limit our scope, not try and do too much, and focus on having success in some places. And soybeans, we can do. And so pretty early on, we would sell this to customers, and they would grow a really beautiful stand of cover crop, usually cereal rye, and they'd plant into it, and like in the upper right-hand picture, they'd get really good-looking beans, and they'd have really good weed control. But we came to realize that here's a little video. So last year we started collaborating with the University of Wisconsin. I think there's another speaker here from the University of Wisconsin. And I think it's really valuable for us to collaborate with universities with these really well-done replicated research plots. There's something that we can get at universities that we can't get just working with end users. Notice they're not doing any row cleaning here, okay? So in organic, any bare soil is a place where weeds are gonna grow. So that ZRX roller crimper device, you can either run it with a row clearing configuration, which you would use in a conventional type of system, or with corn, you can't grow corn this way. With corn, you have to clear a path. And even though I said corn was difficult, I don't believe corn is impossible, and people do have success planting corn into cereal rye cover crops. But you have to focus on the fundamentals, okay? And I think they grew 60 bushel soybeans, organic no-till soybeans this year. Soybeans that you could sell for $19 instead of $9. So when you look at, the entire hypothesis is, okay, you take your costs on one side and your revenues on the other side, and how do we maximize that kind of differential equation? And the possible returns are very high. And I think that there will be kind of a period of 5 to 10 years before everyone is doing something. when there will be a real opportunity to make a lot of money doing a system like this, specifically in food-grade soybeans. So when you look at business, okay, I would bet 90% of people in this room, let me just get a show of hands. How many people in this room think organic no-till would never work for them? There's one. Two honest people. Okay. It's the vast majority, the conventional wisdom is not this, right? The conventional wisdom is that this would be crazy. And so I kind of think of analogies. Okay, what typically makes good investments? Investments that have no risk have no return. The highest returning investments are also the riskiest investments. So if you think of your farm like a portfolio, maybe you could have a diversity in your sort of portfolio. Maybe you do some low-risk things, but maybe you do some high-risk things. You don't. What is crazy is that when you've never done it, doing the whole farm, you don't do the whole farm. You take an experimental approach, which is exactly what we're doing. We don't know exactly where we're going. We're just starting, walking into the darkness, and we're just keeping walking one direction. And we don't really know where it will all end up. We're just figuring it out. And I think that for farms, take the 10% approach. Try 10% of your acres. Try something different. Try a potentially high return, high risk practice on a smaller number of acres. So the other core strategy for us is to say, okay, the vast majority of our clients are, if you're supporting a family farming in the state of Illinois, you're farming at least 2,000 acres. So how do you take a practice like organic no-till soybeans and make it viable on the large scale? So all of these equipment solutions are about designs that at least they are scalable. They are something that you could take out to a production size. So here you see the same roller clipping setups mounted on 60-foot planters, 40-foot planters. On the left-hand side, this is planted cotton. So this is actually down south. One place that we've had a lot of success is in cotton sort of mid-south. And a lot of these clients, here, notice in this configuration, they're running the rotator on the rotator behind the roller. These clients, they're not coming to these systems because they're diehard soil health people. They're coming to these cover crop systems because it's effectively the only strategy which is working at combating the herbicide-resistant weed problems that they have. And so the Roundup-resistant water hemp that they have, they don't get a freeze cycle, and the weed control problems that they have are different. And it's one of the few effective strategies. And this customer right here in western Tennessee, this was actually some of the highest yielding cotton produced in this county with this system. And cotton also, cotton wants to die as soon as you pour it out of the bag. It's not a, you plant it shallow. Okay. So it wasn't long before we got into this that we realized, okay, we've got this phenomenal product that empowers customers to plant into heavy cover crop systems, but we've got a bigger problem in that our customers aren't able to actually establish a thick enough cover crop system to make it work. If you look at this fall, you wait until you harvest your crop and then come in and drill your cover crop. There's just not enough time for you to get enough growth to really make it viable. I mean, when I talked about unpopular thing, I mean, the number of people here that want to be planting their beans on June 1st is probably very small, would be my guess also. So we said, all right, well, we have another problem that we're held back on. We we can't roll the cover crop until we have a cover crop to roll. So we got into the interseeding system, the duo seed, and we said, okay, what is the highest value, lowest cost opener design we could make, just a simple opener design for interseeding to give a great result at the lowest possible price point. Normally, everything we make at Dawn is at the top price point in the category that they're in. And we said, by definition, even though we're looking at making systems for operations at larger scale, the customers in this market tend to be smaller farms than our traditional customers. They're not going into John Deere on multi-unit deals and trading a planter every 2 years. They're not spending quite as much on equipment, so we need to keep everything affordable. And so we said, okay, let's make the duo seed, and that we sell basically at an $800 price point. It's got a parallel linkage, air down pressure. It has an offset disc opener design, like a case planter, and then we flatten the angle so that it's absolutely as small as possible to do the least soil disturbance. And good depth control. And so we've got a really easy system. Typically, people are coming in and running this very early in the sort of V5 stage of the crop. And one of the things I'll tell you guys, I am not an agronomist. I technically studied physics in college, and I have no formal acumen in agriculture at all. I actually learned vicariously through you guys. And I think of myself, like in motorsport, the best relationships happen when you have a driver and a race engineer that have the best race car drivers are the ones that can communicate what the car is doing to the race engineer so that you know how to set it up. And I think of myself as like a race engineer. I just look for things that fill gaps and solve problems that people need, and then try and just put things in that area. So here we have a really good opener. Sales of this product have actually surprised me. The interest in interseeding has really, really surprised me. And so the duo seed is effectively a drill. This is a video I posted on the internet where they're seeding a cover crop into a cotton stand. Also, you can put these on 7.5-inch centers if need be. It reliably grows a really nice stand. It has good depth control. It cuts well. It doesn't do too much soil disturbance. So, you can take a single tool, you can get a single opener, and you can use it for interseeding. You could use it to seed broadacre crops. You could use it to inject fertilizer. It goes 3¼ inches deep. So you could take a single implement and do a lot of different things with it. Couple photos of different crops that were planted with the duo seed. Here you see the strip intercrop system and the relay crop system that's been getting a lot of buzz lately. I gave a presentation over in Ukraine recently, and I talked about this relay crop system, and they were blown away. They were baffled. They were just like, what? No, it's unbelievable. But you plant winter wheat, it starts to grow, you come back in, you drill twin row soybeans in between the wheat or single row. It starts to grow, the wheat matures, you harvest that, the beans come up, you maximize the utilization, you maximize the extent to which you're covering, right? And so there's a certain school of thought that says, okay, well, why not make your cover crop a cash crop? And it makes sense, especially where you have a lot of fertility. So I don't think I'm going to use my full time, but I've got more stuff, and I'm just going to fill whatever the available window is. Okay, so this is where we're literally getting into the weeds. So here's the other thing. Things aren't going to always go right. Things will go wrong. And there's this, across from our test field, we operate these test sites where we run equipment around in circles all summer long. And there's this organic bean field across the road from us. And I kind of watched it all year. And you could see, and I had a huge amount of guilt about this because we let our test fields where we just effectively drive around in circles for 100 hours at a time, we let it go to weeds. And I could see how our weeds were infecting this neighbor's organic bean field. And I felt really bad about it because you could see it kind of creeping in and creeping in and creeping in and creeping in. Just so obviously how the wind was just carrying it from the edges of the field. But the cereal rye system or the organic no-till system, you will get really, really good weed control when done right. But the problem about taking a practice like this and taking it from research use to mainstream use is that you will never get a perfect weed control. You'll get close, and sometimes it'll work perfectly, but you'll never get perfect weed control. So years ago, I was sitting around in an office with my patent attorney, and I was just kind of sketching, and I was like, this is crazy, but who knows? Maybe we'll just try it. We're like, okay, so you're in an organic no-till system, and you inevitably will get some weeds growing in there. So what do? You go in there and you hand pick them. You run the weed zapper system. There's like these electro-weeding systems out in the market where you have this high current thing that discharges electricity into the weeds, which is, I don't think there's any magic solution out there right now. But we said, okay, what can we do? We'll go in there and we'll just cut weeds out. So then we started making the Romo. Because in reality, the tolerance for having your organic no-till field go to hell is low. And that's part of the social pressure around it too. And you see it online. It's like, oh, look at that organic field. The weeds are terrible. It looks bad. You have to keep your field under control. You don't want you want to keep things kind of trimmed. And so we said, all right, well, if we have a situation that goes to weeds crazy, we'll just run the Romo in there. So we thought, all right, well, we'll make this device and that has this guard, and you run it through this field of beans, and it deflects the canopy of the beans around the outside, and it cuts it was a flail, a hydraulically driven flail, and it will just cut the weed material in between the rows. And that was our prototype that we ran last year. And it just kind of worked. It worked enough to realize that there's potential, and it worked poorly enough to make me realize that it's a hard problem to So this unit, we come in, and you can kind of clean up the fields. You cut the weeds out between the rows. That's kind of okay. Then we got into some other conditions, some really, really heavy cover crop conditions, which it's like vetch makes this viney rat's nest. Or at the University of Wisconsin, we ran in this field that was like this thick buckwheat cover crop. Because that's the next generation is where you're using, I'm very interested in systems where living mulch systems where you're using the cover crop not only to control weeds, but you're planting legumes in a system with corn in order to generate nitrogen for the corn. And that's another alternative use for the Romo too. So we'd go into these different fields and it would just bog down. We couldn't get enough power to it because the power management of the Romo is actually is hard, because again, we have to be able to make a system which is scalable and can get out to 11 rows as our target for this year. And so we were generating way too much heat. We weren't getting enough torque to the flail and everything like that. And we said, okay, we need to take an alternative approach. And that's when we made the new Romo, which is a sickle. And I just had this at the National Farm Machinery Show, and people would come by our booth with these looks of absolute bewilderment. You know, just what kind of crazy stuff are these guys up to now? So basically what you do is you've got a vertical shaft that has two sickles, one of which goes between the rows and one of which cuts either rye regrowth or weeds that are coming up through the canopy of the beans. And you can adjust the height of the top sickle. And they move in opposition so that they're constantly trying to balance the forces. They don't balance the forces well enough. And that's like, you've got a lot of energy. You have a lot of energy in that thing. And we definitely need to focus on safety. And, you know, we'll do this. We'll do the safety testing at Woody's farm in about, let's see here, a couple months now. Stand behind it, you know. So you run the Romo through and you can cut it, and then we're also going to be making some systems where, say, you're planting into a living clover, you know, vetch, you name it, cover crop. You can actually take the clippings and brush them over into the root zone area in order to control weeds, and also so that they break down and decompose over the top of the root zone area. Okay, and I think this is just crazy enough to work. Personally, I think this has legs, and it's going to go. So, effectively, what we're going to be doing is running the Romo in a few different areas. Your fearless leader, Mr. Van Arkel, will be one, hopefully. Dan DeSutter down in Indiana will be doing another corn experiment, a zero input experiment. Okay, so you want to talk about some stuff that probably won't work, but the payoff could be really big? What if you could grow corn with effectively no inputs, with no fertilizer? How high of a yield could you grow in corn with no fertilizer? Do we know? Maybe we don't know the answer to that yet. Maybe it's higher than you think. That profitability is actually a differential equation. That, you know, yield is really important. I'm not going to, yield pays the bills. You guys know that. But also, you know, it's a function of two things. It's an optimization problem. And so I put this slide in. I'm going to pivot to different direction now. So to summarize before, the strategy with underground agriculture is we take organic no-till soybeans and we produce a comprehensive set of products that enable real-world adoption for customers. So we try and produce every piece of the puzzle that you need. And part of that's with the planter. And I'm not going to, if I have time, I'll go into the planter a little bit too. Because how you have your planter set up is very important to having success. But I put this slide in here because I was actually at the bar a couple nights ago, and I was talking with some of my team members and their spouses, and we were talking about organic labeling. And I have a daughter, she's 3, and so I go to the grocery store sometimes with my wife and I buy food for my daughter, and you look at it and you're like, okay, well, you've got this food, or you've got this organic fruit, or you got whatever, and it even for me as a quote-unquote agricultural professional, I find it difficult to parse exactly what's going on and what's better and what's not. And one thing that really irritates me is these quote-unquote organic strawberries that my wife buys for my daughter, because, you know, they're flavorless, like bland, all the essential strawberryness of these things is just gone. Okay, but they're organic, so they're great, right? And one of the things that irritates me about organic labeling is the perception that and especially moving forward as you have greater investment and engineering in organic, the perception that organic is somehow by definition better. And I think that there is an opportunity, and there will be very soon, a paradigm in which consumers can actually pay for the nutrient value of food. And I honestly think that younger consumers are interested in the nutrient value of food. And the nutrient value of food, like what gives, when you were a kid and you ate that strawberry in your backyard and you taste one of these strawberries that you buy in the store today, what is the difference between them? Well, part of the difference is in the breeding of these plants, and part of the difference is actually the soil. And I think that the nutrient density of food comes from the soil, and that in the future, people will become, hopefully, less focused on labeling and more focused on what is actually the chemical composition of what we're eating. And I think that in the next couple of years, there's been a couple of different Kickstarters and other things out there, but there will be handheld spectrometers that are able to give you some information about the actual composition of the food that you're eating. Okay, so that we're not getting gamed by labels all the time. We can pay for what we're really getting. Okay, so I'm just going to, because I have time, I'm going to very quickly talk about the planter side of the equation, because it's particularly important when you're planting into green cover crop systems. So we make a system today that takes every adjustment that you traditionally as a farmer would be making manually and fully automates those aspects of the planter. So you're automating the control of the down pressure, the depth of the planter, and the closing wheel performance at the same time. One of the really interesting things about this system, it's a digital electrohydraulic system. We manufacture the system that's on the new John Deere planters. I'm not going to spend a ton of time on it, but effectively what you're doing, and the way most of these systems on the market work, is that gauge wheel load, you have a target set point, gauge wheel load goes down, system increases pressure, gauge wheel load too high, system decreases pressure. And the art form in terms of getting the maximum accuracy out of the planter is to do that as fast as possible. So the rapidity with which you can make a hydraulic adjustment to the system directly correlates with the accuracy of the planter control system. And notice with our systems, we actually use 2 valves. So we use 2 simple poppet valves that open and close in about 30 milliseconds, increase, decrease, increase, decrease. That's how you do it, to try and keep it on the target. And the other thing I'll say, lower gauge wheel load is not better, always. You need, in dry soil, you effectively can't run too much gauge wheel load. When in doubt, you're better off running too much than too little, in my opinion. So we've got the active closing system, or this is the depth control system, which can actually change how deep the planter is planting in real time. It will also map the bumpiness, the true surface of the field. And for this spring in Kansas, we'll have a system that adjusts the depth of the planter for the first time based on soil moisture, so that you're changing how deep the planter is planted based on how wet or dry the field is. The RCX closing wheel. Now this is good for organic no-till soybeans, right? So you're planting, you've got a mat of residue this thick, and you're trying to plant into it a bean that you want to plant that deep. So how do you do that? First of all, you get really good seed to soil contact. And so we have this new closing wheel system that has a rolling firming wheel to firm the seed down. And then it casters side to side to keep itself steered and centered on the row. And what it does is it actually measures, so it takes this firming wheel, okay? And the firming wheel runs in the bottom of the furrow, and that becomes effectively a datum line of where the seed depth is. And then we're measuring the relative depth between the closing wheels with a sensor and the bottom of the furrow, and we're hydraulically adjusting the closing wheels so that they maintain a fixed position relative to where the bottom of the furrow is all the time. It's not a pressure control system, it's actually a depth control system. Okay, and it makes a appearance to the soil after you plant that does not look like any typical closing system. It doesn't leave a conventional kind of double line where the closing wheels run. And so what it's doing is you're again setting a deadband. So you're saying, okay, if the position of the bottom of the closing wheels relative to the bottom of the furrow changes more than a 1/16 of an inch, we will decrease or increase the pressure. All of these hydraulic systems are hydropneumatic to make them less jerky. They all have a nitrogen pressure vessel, and they're all digital. Instead of using a pressure control valve where you're driving coil into it and trying to control the pressure with like a reducing relieving valve, we're pulsing. We just go just pulsing little tiny bits of oil in or out as fast as you can. One thing that really irritates me when I go out with my customers is the closing wheels on the planter are always off. They never stay straight. And I stopped suggesting to customers that they should put their closing wheels in the staggered position anymore because it makes them over time steer off. And if you have a larger planter, the worse it gets. You'll notice the ones at the end of the frame are always, because there's just a slot there, and they're never on center, and it drives me crazy. So this system actually casters in order to, great sideways video, Joe. We're thinking orthogonally here. So the part of this, it's just showing how sharp in the ground you can plant with it still close in the furrow. So if you do a lot of turning in the ground, a lot of uneven terrain, turning in the ground, that's going to be a good fit for you. You can see the kind of really beautiful sort of seed to soil contact you can get out of that. So we have this year we're moving to a iPad-based control system that actually has 7 different data layers that you'll acquire while you're planting. So I believe in the future, and this is almost the right brain and the left brain part of the earlier part of my presentation. When we manufacture things, we make really high precision things, right? And we use like these coordinate measuring machines in order to check our parts. And we get these ones from Carl Zeiss. We have 2 of these super high precision machines that effectively are the basis and the standard for all of the dimensional accuracy of everything we make at our company. And I do believe that in the future, your planter will be almost like a certified instrument, that you, as the operator, will have very little, you'll pay a ton of money for it, but you'll take it to the dealer and you'll get a certification, and it will effectively be an instrument. And you'll be able to plant, And if something goes wrong, you'll be able to hand somebody a piece of paper and say, sorry, my instrument was calibrated, and that's what the future of automation is going to give us. That you're going to be spending more money, but you will be not having to, you will in some ways have less risk because the equipment will become calibrated in some way. Like here, you're planting, okay, you're a custom planter and you plant your field for a customer, and you can say, he says, oh, the seed guy probably blames the planter, and he says, oh, he planted it too shallow or something. Because the seed guys always blame the equipment guys. And you're like, nope, here's my certified report saying exactly how it was planted. Oh, and it was planted at this depth. And this was the target depth, and this was the actual depth at this position. We're moving to a 5 hertz data frequency, so you're getting 5 data points per second out of it. And you can see every parameter about how it was planted. Okay, back to cover crops. The closing wheels are going to be a really big deal. Well, first of all, the biggest deal is if you want to have success planting into a really heavy cereal rye cover crop like I was showing earlier, you must do one thing. And the one thing you must do is to have the narrowest possible gauge wheel on your planter. There are ones on the market now that I believe are only 2 inches wide. So your whole width of your planter is like this. The narrower it is, the less crop material you have to push out of the way in order to get. Just because you're planting green doesn't mean you don't have to focus on the fundamentals. And one thing that drives me crazy every spring is when I look on the internet and I see, oh, I'm planting green and blah, 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 because whatever, well-intentioned extension agent has convinced me to plant green, and I hate that stuff because you're not set up right. If you're not set up right to have success, I'd rather you not do it, because if you have a terrible outcome your first time, then you're going to be turned off and you're going to for the rest, and it'll be impossible to get that person who was otherwise willing to try a new practice to get them back into it. Don't try it if you're not set up right. Okay, the 2 things, you have to have narrow gauge wheels. And you basically need to have an automatic down pressure control system on the planter, whether from us, whether from a competitor, from anybody. Those 2 things. And 3, you have to have a lot of weight on your planter. 300 pounds per row, minimum. And I'd like to have 500. Lots of weight, narrow gauge wheels, automatic down pressure control system, and then those things are first. At the end of the road, then get into a closing wheel, okay? Something like the gauge tine up top, we make a short tooth closing wheel, doesn't want to wrap up. There's a smooth cast wheel. All of these closing wheels fit on a single hub. So most of the cost is in the hub, and you can fit different wheels onto the same hub, okay? But your biggest problem is not likely to be your closing wheels. Get the seed in the ground before you worry about covering it up. Okay. I'm running out of time here, so I'm going to kind of move over closing wheel talk. You guys, closing wheels are, one of the reasons why we came up with the automatic closing wheel system was a recognition that there's 20 or 30 different no-till closing wheels on the market right now. And anytime you see such a proliferation of different designs, to me it basically says, we're not solving a first concept problem. The reason why there's so many different individualized little closing wheel designs is because everyone is solving for a localized kind of condition. Everyone's solving for some type of local condition. But the real fundamental problem is depth control. So the broader theme around everything we do is about controlling depth. With ground engaging equipment, the vast majority of performance-related issues come from changing the depth that something's going into the ground as you go across the field. Gauge time, pocket wheel, curve time. They last a really long time. there's good products in the market. There's been a real growth in these kind of lower cost plastic closing wheels. They're okay, and especially if you do a conventional tillage, those things are fine. What we're going to give you is we're going to give you a wheel that costs 30% more, that lasts 200% longer. That's what we're here to do. The hydraulic road cleaner products, you guys are familiar with this kind of stuff. They're frame mounted. They take the force on the road cleaner off of the row unit. It's remotely controllable. You can just turn around, look through the back window, and just kind of dial your knob, get an immediate result out of it. It's a trailing arm instead of a pushed arm. So, you know, the analogy is, would you rather push a heavy wheelbarrow uphill or would you pull it? That by being pulled, it just inherently follows the surface of the soil better and doesn't do as much, clears the residue without doing as much soil disturbance.